Good afternoon from me. The presentation that the paper that I'm presenting is experimental investigation on mechanical properties of FFF parts using different materials. This is part of a larger research that we are conducting in order to design complex structural parts. So as the presenter before me explained, the additive manufacturing is are new technologies that really rise in popularity, mostly because the possibility for designing a very complex part. The process of fused filament fabrication that we are applying is one of the most widely used. We want to conduct experimental analysis in order to define the mechanical characteristics of the fabricated polymer parts, because as we all know, there is a lot of difference between the fabricated polymer parts and injection molding polymer parts. We are conducting this research in order to choose the appropriate material according to the application. As I mentioned, our application are structural elements and finally design of complex composite structures. So there are a lot of research in this area, but we did not find many research that are comparing different materials. Most of them are comparing the process parameters. So we designed the samples according to the standards that are standards for the polymer parts. And according to the standard ISS 527, we designed the sample for the tensile strength, and we designed three samples for the experiments. And for the flexural strength samples, we used the ISO 178. As you can see on the picture, those are the samples. We used a fused filament fabrication process. And we use the machine Prusa MK3 and the Prusa in-house material Prusament for obtaining the best results. And the three materials that are comparing is PLA, polylactic acid, PC polycarbonate, and polyethylene terephthalate glycol or PETG. We use the same process parameters for all the samples except the temperature that is needed for the different materials, but we do not change any of the process parameters during the fabrication process. For the experiments, we use Shimadzu machines, Shimadzu AGX-S for the tensile strength and the flexural strength Shimadzu AGX. On the slide, you can see the samples that we use for the experiments, and on this slide you can see the results from the tensile strength. The results are as we expected, and as you can see on the probes, the PLA is completely broken. The material from PETG showed some stringing. And the polycarbonate is completely has plastic deformation and showed the most elasticity. On this sample, on this slide, we are presenting the separate the tensile strength on different all the three different materials. As you can see, the PETG has the least force. And these are the stress strain diagrams. I will go fast in the interest of time. These are the results of the flexural strength. Again, the PLA is completely broken, and PETG and PC have plastic deformation, which is again showing that the PLA is very rigid compared to the other two parts that have more flexibility to it. In conclusion, as we wanted to design composite materials, we will need more flexural materials. So we will be using polycarbonate of PETG. We wanted to combine it with a carbon material. So it's going to be, we are not making mixture, but we are making like functional grading. So we combine the materials in some of the layers in order to give better results. And for following research, we are planning a test sample with variation of the infill of these two materials, and then variation of the printing orientation in order to obtain the best quality, and also combination of materials to achieve the result that we are needing. So thank you for the attention, and if you have any question, feel free to ask.